Good evening, students. We are going to see the phenomenon of crystal field splitting in octahedral complexes. So, for understanding the crystal field splitting, this phenomenon in octahedral complexes, we must know that in order to form a complex, the central metal is approached by certain ligands. For example, the central metal is M here, and a number of ligands come close to this M and they form the coordinate bond with central metal. So, central metal is approached by ligands for formation of the octahedral complexes. So, this central metal has the d orbitals, and d orbitals are 5 in number. These are 5 d orbitals of central metal. This central metal, these are the orbitals of this central metal, and these are degenerate. Degenerate means they have similar energy. These are the degenerate d orbitals of central metal M. That is, when the ligand has not approached, then the orbitals will have same energy, and we will call them degenerate d orbitals of the central metal. As the ligand approaches for the formation of the coordinate bond, the degeneracy of the d orbitals is destroyed. That is, these degenerate d orbitals, they split into two groups. One group is called T2G, which contains 3 orbitals, and another group is called EG, which contains 2 orbitals. So this phenomenon takes place only when the ligand approaches the central metal. These are the degenerate orbitals of the central metal, and when ligand approaches, then the degeneracy is destroyed. It means the orbitals which had similar energy, now they will split into two groups. One group is T2G and another group is EG. They will divide themselves into two groups. Now, this energy gap between T2G and EG is arbitrarily taken to be 10 dq. 10 dq is the arbitrary value taken by the scientist for explaining this T2G and EG energy gap. So this energy gap is taken to be 10 dq. And in the octahedral complexes, this energy is taken to be 4 dq, and this one is taken to be 6 dq. 6 and 4, the sum will be 10. That is, this is the normal level of the energy of the degenerate d orbitals. So 4 dq is below this level and 6 dq is above this level. That is, EG orbitals will have energy greater by the value 6 dq from this level, and they will have lesser energy than this level by 4 dq. So this is the energy separation, which is 10 dq, and 10 dq is divided into 6 dq and 4 dq in this way. Now, when the ligand which is approaching the central metal is strong, when the ligand is strong, then this splitting is more. That is, this gap between EG and T2G will be greater. This is the EG group, this is the T2G group. In T2G group there are 3 orbitals, and in EG group there are 2 orbitals. So this splitting will be more if the ligand is strong. That is, this gap will be more. And when the ligand will be weak, then this gap will be less. You can understand that this is EG and this is T2G. Now you can see that here the splitting is less because the ligand is weak. When the ligand is weak, then this splitting will be less, and when ligand will be strong, then this splitting will be more. So this phenomenon in which the degenerate d orbitals split into two groups is called crystal field splitting. This only is called crystal field splitting, that is the splitting of d orbitals into two groups T2G and EG. And this splitting will be more when the ligand approaching the central metal is strong. And when this central metal is approached by a weak ligand, then this splitting will be less. So this splitting is more or less, it will depend upon the nature of the ligand. Now, when we have a strong ligand which is approaching the central metal, when ligand is strong, so the splitting will be more. That is, the gap will be more. That is, EG and T2G will be far away from each other. And when we start filling the electrons in the d orbital, these are d orbitals only which are split into two parts, T2G and EG. So suppose you are filling the electrons, so T2G have lower energy and EG have higher energy. So electrons always try to get filled up in the orbitals of lower energy first. So if we are filling the electrons, suppose the configuration is D1, and we have to fill just one electron, then one electron will try to remain in the lower energy level, which is T2G. So one electron will be filled up here. Then second electron will be filled up here. Third electron will be filled up here. Now, when the fourth electron is to be filled up, then it has two choices. It can get filled here in the EG, or it can get paired up in T2G. Now, since the ligand is strong, this crystal field splitting is more. That is, this gap 10 dq is very high. This gap is more. And an energy required for getting paired up is called pairing energy, which is represented by P. That is, if this gap is high, that instead of fourth electron going in EG, because there is a large energy gap, so instead of getting filled in EG, it will prefer to filled up in T2G and will prefer to get paired up. Why? Because pairing energy is less than 10 dq. This is 10 dq. And 10 dq is very high. So when 10 dq is high and pairing energy is less, it means instead of going here, it will try to get paired up in T2G. Why? Because pairing energy is low. इसको pair up होने में कम energy लगेगी rather than going into EG. So it will try to get paired up and the fourth electron will be filled up here. Likewise, fifth will be coming here and sixth will be coming here. Why are they trying to get paired up? Because the energy required for getting paired up is less. The pairing energy is less and this gap is more. So if the fourth electron gets filled up here, it will require more energy. And if it gets paired up here, then it will require less energy. So it will try to filled up, try to get filled up in the T2G only instead of going to EG. It will try to get paired up rather than going to EG. So this way, fourth electron, fifth electron, sixth electron. But when seventh electron is to be filled, now T2G is completely filled and they have no choice. They have to get filled in EG now. That is when T2G will be completely filled. Suppose the configuration is D7. So 1, 2, 3, 4, 5, 6. and the 7th electron will now come here. Likewise, 8th electron here, 9th electron here, and 10th electron here. That is, when the splitting will be more, when the ligand will be strong, then this splitting will be more, and when splitting will be more, then pairing energy will be less, and 10 dq, that is, this gap will be greater. So when this gap will be greater, so electron will require more energy to get promoted here, to get filled here. So what will it prefer to do? It will prefer to get paired up here in T2G. Why? Because the energy required for getting paired up is less. So instead of going into EG, it will try to get paired up in T2G only. So filling will be taking place in this way. Suppose this is T2G and this is EG, and the ligand is strong. So first electron, second electron, third electron, then fourth electron, fifth electron, sixth electron. And when T2G will be completely filled, then electrons have no choice except to go to EG. So 7th electron, 8th electron, then pairing 9th electron and 10th electron. This is why we say that in the case of a strong ligand, they cause pairing. Why do they cause pairing? We understood it on the basis of crystal field splitting phenomenon. On the other hand, when the ligand will be weak, when ligand is weak, then the crystal field splitting is less. That is, 10 dq is very small. This is EG and this is T2G. Now this gap is less. This gap is less, but it will remain 10 dq. We represent it by 10 dq only. So in the strong ligand, this gap was more, and in the weak ligand, this gap is less. So what will happen? If you are filling the first electron, it will come in T2G because it has lower energy. So first electron, second electron, third electron. Now fourth electron has two choices. It can get paired up here or it can go to EG. Now this gap is small and the pairing energy is greater than 10 dq. That is, if electron goes here in EG, it will require less energy, and if it gets paired up here, it will require more energy. I said pairing energy is greater. So when pairing energy is greater, then electron will try to go to EG rather than to get paired up. So the fourth electron will come here and fifth electron will come here. And when sixth electron has to be filled, now pairing will start. So 6 electron here, 7, 8, 9 and 10. That is, if the ligand is weak, they try to remain unpaired because they will be filled in T2G. So they will remain unpaired, and when they will be filled in EG, then also they will remain unpaired. Why? Because this gap was less, ligand was weak. So instead of getting paired up, it is easier for them to go to EG. Why? Because 10 dq is small here and they can easily go here. And pairing will require more energy. So when all will be singly filled, then pairing will start. Why? Because then they will not be left with any option. Then they have to undergo pairing. So this way, weak ligands, they give rise to high spin complexes. Why? Because electrons try to remain unpaired as far as possible, 1, 2, 3, 4, 5, and then pairing starts. On the other hand, strong ligands, they cause low spin complexes. Why? Because electrons try to get paired up. So when pairing will be taking place, then spin will be low. So this is how crystal field splitting takes place in octahedral complexes in a strong and weak ligands. In the next video, we will see the calculation of crystal field stabilization energy. Thank you.